Today's lesson, we learn equivalence equation. However, before we get into the equation, into the detail, the math, we want to know and review what is the equivalence, and that we talked in the previous lesson, and that I want to go to the note of the previous lesson, and you can see here, note 9. And equivalence, by definition, is the different sums of money at different time are equal in economic value. So that is the definition of equivalence. And from that, I use one example. If you Google Big Dick, then go back to the project called the Central Artery Tunnel Project located in Boston, Massachusetts. And if you recall in lesson 8, when we talk about the project delivery method, I use this project as an example that they use the construction management agency, CM agency, as the delivery method to manage the designing and building process for this project. But now we interest about equivalent, and you by that this project have many tuples that you can read in the wiki. Just Google Big Dick, and I copy of some of them just to show the concept of equivalence in today's class. So with that, let's go to the, and I copy that from the wiki here. You can read in detail, but let's go to the PowerPoint that I copied from there. So here you see the project that include the highway, the tunnel, and elevated road that are in the Boston, and that is I copy from Wikipedia. And let me read. The Big Dick was the most expensive highway project in the US, and continue, but I just eliminate unimportant that I want to emphasize for today's class. The project was originally scheduled to be completed in 1998 at an estimated cost of 2.8 billion in 1982 dollars, and that 2.8 billion in 1982 dollars equivalent to 6 billion adjusted for inflation as of 2006. So the project you see spanned from 1982 to 1998 with each 16 years. That the original estimate, and the cost is 2.8 billion in 1982 dollars, or equivalently 6 billion in 2006. So that you can see the different amounts of money, 2.8 billion and 6 billion are equal in economic value in this case after 24 years apart, 1982 and 2006. However, the project was completed only in December 2007, which is, you see, delay from 1992 to 2007. So it's about 9-10 years. So from 16 years to 25-26 years at the cost of over 14.6 billion. So it means what? It's equivalent to 8.8 billion in 1982 dollars, meaning the cost overrun 190% as of 2006. So what does that mean? As you can see, you have to compare. You cannot compare the one estimate originally 2.8 billions with the 14.9 billions, because we need to consider the time value of money. So that compared with the years 14.6 billion in as of 2006, it equivalent to 8.8 billions in 1982 dollars. So we compare that with that 2.8 billion originally estimate. This project exceed 119, so almost 200% overrun. Make sense? So the project delayed almost 10 years and then overrun 200%, and that you see the equivalence with the number there. So when we talk about the monies, we need to understand the concept of equivalence. Different amounts of money at different time have same economic values, and that what we do today. How today lesson, how we convert different amount of money that consider equivalence. That we talk about equivalence formulas or equation. Before we get into the detail of other the lesson videos, I want to give you some definition of different factors, different values that we want to define before we get into the detail. So the symbols and their meaning. The first, the P, is the value of money or amount of money at the time denoted at the present now, and call that in present cost or present value in dollars. So P stands for some money now. It had P. F, future. So the value or amount, only one single value, like P, value or amount of money at some future time, and that called future cost or future values in dollars. So P, some values now, F, some value in the future. But they have relative meanings. If you have two amounts located in the same on the time scale, then relatively the one located prior called P, the one located later, if you convert, it's time consider F. So that the future and present value. The next one we call it A, the series of consecutive equal end of period amount of money, call that equivalent value per period or annual cost. So annual does that mean it always the amount per year, and you can see the unit can be dollars per year or dollar per month, just like you pay a mortgage or buy a car, pay every month, that is dollar amount, that same amount over and over, that is A. Make sense? So those are the P, present value, one single amount. F, future value, one single amount in the future. A, uniform amount consecutively over a period of time, can be dollar per year or dollar per month. Even A, they call it annuity, is something annual, but don't need to be per year. It can be per month, per day, etc. So keep that in mind. And other simple, and the number of interest periods, year or month, depends on days, depends on how the problem state. And interest rate per interest period, that is percent per year or per month. And T, the time stated in the period. So if the problem say, okay, pay monthly payment, so that month. If we say we receive the income every year, then it's year. So that have to be compatible with all of the information F, P, A that we talked in the previous slide, and the NIT in here. Make sense? So understand what is P, what is F, what is A, and later on what is G in today's class with the uniform gradient change. Very important to apply the equation and the table properties. That is the first thing I want to. And then the reference today, we again the exam2 reference. We have equation, and we will go over all of this equation in today's class. And you can use the equation directly, or you can use the table with different interests, and that we'll walk through for today's lesson when you watch in the next lesson videos. Okay.